Okay, hello. What is that? Please close the door. Weird effect. So yeah, I was like given the opportunity to like welcome you, and because it's a fantastic place to give some propaganda, I gladly do that. As you all know, coders are probably like the kilogram price of coder is like greater than palladium at the moment. So when I'm selling you to like interested parties, I'm gonna get lots of cash because coders are in such short supply. So yeah, anyways, I know that you've all been like dreaming of Fraktio the last few nights waiting for the event, but I heard that some of you people didn't even know what Fraktio is, so I'm just gonna like tell you something. We do web applications and mobile applications too, and we were founded like 6 years ago by me, Bekkis, and 4 of my friends. And today we have like 30 people. But this is not enough. Much sales, much growth, so we need coders. And if you'd like to come and work with us, this is how it works. You come here 5 days a week, 8 hours per day, and then we give you money in the end of each month. We call this salary, and it's basically how it works. We've been revolutionizing this work life with this concept. So yeah, and of course I can say anything because all the consultant houses are like great places to work. But we can offer an indoor job, of course, and somewhat interesting projects. Yes, and interesting co-workers with great skills and fair compensations and okay benefits and award-winning culture. Yes, we've been like participating in the great place to work and somewhat like succeeded. And a chance to grow with us, like physically eating the pizza and mentally, well, like getting better. So please apply. We are going to pay you money. Yeah, and so basically the practical information for today is that the schedule is like 2 presentations first, and then a break, and then 2 presentations more. And the fridges are filled with stuff, so just go and take from there. And there seems to be some pizza, so eat it. And sauna is located there, and it's hot. So after the show, just go to the sauna. And movie theater, which is there, it's from the 50s. This is the old office of the Finnish Movie Investigation Bureau or something like that. They like censored all the movies for mostly political reasons when the Soviet Union was still like alive and stuff like that. Yeah, every movie that was like shown in Finland till the 90s was like watched here. So that's nice. And all of our people can be identified by their vile smell. So please talk to our people if you like want to know more about us. And make yourselves at home. Everything is yours tonight. The world is yours. Yeah, so I have nothing more. I have no idea who is going to hold their presentation first, but probably the presenters will know. Are you the first?
Yes.
Yeah. Come here.
Can I use the mirror? Oh shit, it's just really small. have to ask, does everyone see the mole's text?
Can't see the console.
Can we make it?
I can see it.
Yeah. Okay, so first, a little bit about myself. This is actually the first time I'm ever talking publicly in English, like in these conferences. So, wish me luck. I'm Tommi Keskitalo. On the internet, you can find me as Civixia. I'm currently working at Fraktio, one of our consultants/developers. I have mainly done web. My background is from PHP, and nowadays it's plain JavaScript. What I do like is this old-fashioned CSS, debugging, refactoring, automation, fancy code, and all kind of stuff like that. What I don't like is numbers. I don't get well with them. And I usually use Chrome and VS Code. I'm really fan of Google stuff, so let's see. So, source. When we are debugging, we always want to use the source code. That's what we have is source maps. Nowadays, everybody is using Bubble, Webpack, and everything is minified and uglified and blah, blah, blah. So we have source maps, so we can actually see what the code were before it went in distribution. And that's so everybody is in the same page. First, to me, it feels like console log. Everybody knows this already, and to me it still feels like it's the most common way of debugging, even though we have these other great tools. We have console log, we have console debug, we have table and count. I don't know how often people actually use those, but to present them easily, when I click the button, I can see the console log giving me the new stuff. And if we actually go in source and find console app, so this is the source map. We can see there is the decrease and increase button. Another is console logging and another one is debugging. So in here, when we press the button, the number changes. And funny thing is to notice that it's actually not the same one because we are logging it before we actually change the number. So, and when we press the other button, it doesn't show us anything. And this is actually a funny thing I like to use a lot, because in verbose, this reduces all the noise there is with logging. If you are using hot reloading and all the other fancy stuff, it can get really noisy as fast, so I always use console debug. So when I press it, I can actually see this is the interesting stuff I'm interested in. So, like in all applications, there's always like IaaS request and all the other stuff. And from the API we are interested. I made a one so we can get the users. And what it actually does, okay, cannot read property first name of undefined, most common. Anyway, so we get the users and we can actually go see what is there. So it's quite clear we are getting users from user services, and then we are for each everyone and we want the first name from there. So we initialize debug and run it again. And now we get all what there were in before we start iterating them. And this is also getting really noisy. In my opinion, I don't like to read these. For me, finding the book actually doesn't help much. So what I like to do, let's clear that, is use in-build debugging tools. One of my go-to tools is debugger keyword. It's something I can put in the code, and I know when it's running there, the code stopped working. Not stop working, it pauses. And it's really easy to know if you know, okay, that's where the error is going to be. I break before it, and it allows us to evaluate the code. So there is the call stack, which nowadays I don't find that readable anymore. But cool thing is the scope. I can actually see what there is. So this, and then there's the closure, so I can find the users. There's the breakpoint, so which is referring to the component, and all the other stuff. I can even go to see the users' services that is available there. And this gives us lot of freedom to do. Because what I can actually do is evaluate code while I'm in paused. So I can ask users, okay, I know there's stuff, find users, start name. Okay, I'm actually interested in the ones that doesn't have the name because we know it was undefined. So okay, I can find one. What about if I filter? Okay, there's only fun, map, name, like ID, for example. Okay, we found one. And what we can do is copy it and go from there. So this is kind of handy because it reduces a lot of work to do, going there, iterating a lot what there is and what we can do and other stuff. And having breakpoint there, it's even funnier because we can go inside the for each and all the other stuff, and we can actually see, having breakpoint there, we can see each users as individuals, and we can debug even deeper. We can go inside the functions, we can jump over them, step into, and once we are done, we can say, I don't care, deactivate breakpoints, and continue and move on. So even though we are iterating through objects and lists and all the stuff, we can only do it when we need it there. But this needs code changes. So there's better ways. Actually breakpoints. So what we can do with breakpoints is just click them and say, okay, I want you to stop there. And let's say even there too. So when I get the stuff, it stops. And now I have all the same possibilities available with Debugger, but I don't need code changes. And with these, it removes less my work I have to do before I start debugging. I can go straight away and start debugging what were the issue. And with these, I can even go like when we are iterating them one by one, I know the issue was that name wasn't there. So I can add watches. Who of them or you have ever used this? Okay, so this is kind of fun for me because I use this a lot. So we can a type of uname undefined. How lucky of us, first one. So let's try to get the second one to get better demo effect. So it's an object. When we go through, it's an object, it's an object, it's an object, it's an object. So it's an expression we are looking for. And what I like to do, okay, now it stopped because it was undefined and the code breaks. We can actually edit the breakpoints and use the same kind of stuff. So we know when we want to actually stop. So uname equals undefined. Undefined, is it that correct? It looks like. And when we run it, it only stops when we know there are going to be an issue. So this reduces the time I have to go through the code, add the breakpoints there and all the other fancy stuff that should be really easy for me. And this gives me that freedom to actually debug. Now I can see straight away the user with uname is undefined is the one that breaks the code. And now I can go in whatever place to look what it does actually and why it's not available. Okay. So those are the basics tools I like to use a lot. But that's in the browser. The second biggest part, like nowadays everybody is running Node on the server as well. When you run the node, you can say inspect or use inspect break, which is basically the same, but it pauses as soon as it can, like the first wherever it breaks. And let's see. Can we make these bigger as well? Yes. So what we can do is actually inspect. This is a small script that I have written. And when we run it, we can open the dev tools from here. This is really small, but it's code //inspect, where we can open the developers tools for Node. And when we run inspect, it runs the node with inspect, it attaches the debugger. And when we go see the console, that's the basic one, localhost 300, and now we know we are there. And to actually go see what the get user does, we can see our code. And similarly, with breakpoints, we can say, okay, we know the name is the one that causes us harm, so break there before anything happens. And where's my... there. So when we get the users, we get the breakpoint there. And this is kind of similar way. We can have the same tools in front end and back end. We don't have to switch nowadays anymore because Chrome supports basically everything. And we can go even higher, like we know the amount is 16 nowadays. So we can do the same here. Amount, it's 16. What if we say it's 5? When we run the code, it updated. So we skipped a few. So we can do like all kind of debugging while it's paused and go even like see the services, what they can do. And if I go say like faker, which generates me random stuff, I can ask it faker, addresses, city. So I don't even need like web service to use faker. What I can do is run simple Node project that imports the faker, add a breakpoint there, and do whatever I want with the faker in my own browser with this Node developers tools. And to me, this is kind of super handy. Let's stop that. We don't have... So let's start running again. So that's what we can do with the servers. And of course, as we are developing web, and nowadays everything has to work on the mobile, Chrome supports this as well. There is this ADP. If people are install it, we can actually use our Webpack configuration, not the one that it's in production, in my phone itself. So in inspection tool, I can see there's my phone, and I can inspect the Chrome on my phone, and I have it here open. So in same principle, we are in same presentation that is running actually Webpack here, 8080. So I have my Webpack version running on my phone, which is hot reloading and has all the other stuff that you have in your browser while you're developing. And once I press that, I get the same tools I were using when I was developing the front end. And now I can actually use the phone and see how it reacts, how it works at the debugger, see like the code itself. I can go even say the network stops or check the elements and all the other stuff that is really easily available for me. I can even go say Redux stuff, even though I don't have this Redux on mine, but I could use that on my phone. I don't need to export it anymore, use the dist or make all this proxy stuff otherwise. Google has those available. I don't know on iOS, I haven't had one, so I haven't used, but this is what I like actually use a lot. So back to presentation. So having these basic tools give us a lot of freedom, like how we can test. And for me, debugging is always when you are developing new features. You want to test them. It never works. And it's all about finding bugs when you are writing them. For that, we have unit tests and we have code review in proper Git history that we can blame the users that made the mistakes. We have to kind of like pull the trust on our code. And as sooner as, and like in smaller iteration where we can find the issues in all the devices and backend and all the other stuff, it gives us more flexibility. We are guessing less and talking more and thinking less and doing more work. And like the mentality is that debugging is always like collaborative effect. There's always the one that write the code Then there's the ones that are using it, finding the issues for us, and then there's the ones that are actually resolving the issues. And to me, debugging is always a big part of the early development phase, where we find most of the issues. Later it goes, the harder it gets. There's like good tools like Sentry, Booksnack, Airbreaker, Travis, and all the other stuff for catching bugs that people should use. They're like tests. And to me, source code is my best friend. And I have found this good policy that no solution in life can be fixed in 5 minutes. So like in normal situation, if you like to do something in hurry and you like to make it work fast, it usually takes longer. But having the close iteration loops, it can make it easier. It doesn't make it faster, but it's always fun to have. I wanted to point out those two like great articles and pages. One is the debugger mindset, talking about the 5-minute solution, and rubber duck debugging, which is one I really like. So I'm really talkative when I code, which if people doesn't know what that means, it means that you have a rubber duck you can talk to and explain your issues, and while you are talking, you can usually solve them. Oh, too fast. So, what to take with you? People will always be human. There will always be bugs. Some issues are not best to resolve by technically, but there are great tools that can you actually help. And personally, I like to use Chrome a lot. I know there's like VS Code integration and all the other stuff, but for me, Chrome is the best one I have used. And Breakpoints gives you great insight what's happening inside of your code. You can actually play with it while you are running it and debug it, and even find new features you didn't know were available. Like you can go in React stuff and see, okay, I have Impress. You can actually go and read the code that were written, and you can find new stuff there. You can even add breakpoints, and now you all know what you can do with those. So, to me, it's always less I have to think, more brain capacity I have for everything else. That's the presentation. Thanks. Any questions?
Watches can be used for something else but loops, right?
Sorry?
Watches, they can be used for something else, not just loops.
Like yeah, basically they can use whatever. They are like expressions. So whatever you can basically write in JavaScript, you can use in watches. So you can, mostly of the time I'm using them to type checking and all the other stuff that isn't that great in JavaScript itself. So if I have like errors that I'm assuming there's a string and it's actually an integer, that's really fast way of me to actually see what it is, and that's where I use them. But of course you can use them basically whatever you can.
But if you use TypeScript, is it still handy with TypeScript?
I haven't used much of TypeScript, even though I really like types. I'm been more using Flow, but should be possible.
Watch is not just used for the tab. Watch can be, it's an observable basically. So what watch does, it just watches for the state of the meaning of certain variable, for instance. So for example, if you want to know why the variable returns undefined, for instance, it's some kind of a weird function, you can watch that variable basically there. So it's not just for the types, it's for anything.
It's like a conditional breakpoint, the one edit breakpoint, right? If you add the breakpoint and you add an edit breakpoint, there is an input, and you can add something there, so it's basically the same in some way.
You can basically put a name of a variable there, and if we watch the
yeah, you can like say it's uname, for example, and it says, and it's an object, and this is what it has. If that's what you were asking, kind of, right?
Kind of.
You can also use the watches for doing assignments or otherwise mutating the runtime state. Just add an and false at the end, so the breakpoint doesn't stop, but it still executes your code.
But I wouldn't want to do that.
It's handy when it's code that it's not under your control. Also, for example, on somebody else's website.
Yeah, but actually there's this funny way that you can do local modification on your browser. This is really handy feature actually if you go like in source, source. You can actually go there and see override. So basically you can override whatever in whatever page, even like background colors, JavaScript code and all the other stuff, and it's local override. So that's kind of loses your purpose.
Yeah, well, good to know about that.
I actually had a nice presentation, but it's for the next meetup, so.
Any more questions? All right, next one, me.
Thank you.
Hei, ota tosta tommoista.
All right. Can you hear me? All right, cool.
All right, well, let's continue.
How's it going? I'm Matt. My coworkers have given me the name of Matti, so I answered either one. I work at Unity. I'm on, as of the last kind of like 8 weeks, I've been kind of in charge of the JavaScript portion of our new AR ads initiative. And so what's interesting here is that we've been trying to make AR work with web technologies because all of our ad stuff actually functions inside of a web view. So we've been trying to get that to work. And these are kind of like our findings from that. So we're going to kind of go over on a high level how WebAR works, as well as the dependencies, kind of some somewhat pseudocodey, but mostly working WebAR examples, and then some, well, not some examples, but one example of something that we've been working on that we're pretty proud of. So how it works. On a high level, it's kind of not just all the JavaScript doing everything, but the native side actually does quite a bit. So the native side initializes and manages an AR session with either ARKit or AR Core. And that's all managed by the web view that's containing it. The JS kind of requests this to start happening, so it doesn't just start and go all gung-ho. The camera stream gets rendered either underneath the web view, or it can be passed through to it. There's a couple other ways to do it, but rendering it below a transparent web view has proved the easiest and the best for us so far. And there's this AR display, which is an extension of the WebVR spec. And that actually serves as like a manager for all of this on the client side. So every single time the frame advances on the native side, it actually passes all of the information to the JavaScript. So all of the view matrices, projections, pose data, all of that gets, in some cases, JSONified and passed along to the JavaScript. And then in some cases also light estimation can be passed through. And then from there, the Three.js camera updates every single frame based on that frame data so that we get the exact same kind of thing that would happen with the native cameras. Planes and anchors are updated via events. So they are handled slightly differently, but still not too bad. There are some restrictions with this. Can't do face detection, so sorry, can't do any Snapchat filters. It's not part of the official spec for WebXR, but I'm sure it will be at some point because a lot of people really like Snapchat filters. And we've tried doing client-side version, but I highly recommend not trying it yourself because it was absolutely awful. Object recognition is kind of the exact same. You can do some stuff on the native side and make a separate bridge that will pass that information along to the JavaScript, but it's maybe too much work. And again, it's not part of the official spec. So whenever this does eventually make it to browsers, it's not going to be supported. Client-side image manipulation is kind of a yes and no. On the, there's like 3 browsers that this works on. On 2 of them, on very specific versions of iOS, it passes the camera frame along as a base64 image. On that, you can do client-side image manipulation, but everything else you can't do it, apart from like a full screen filter with some sort of color on it to change the tint or something. But either way, it's really inefficient, so it's not really a good thing to do. The dependencies for this, there's basically 3. You can choose from whichever browser you want to actually use. There's 2 from Google, WebAR on ARKit, and which you can kind of guess that one's for iOS. There's an Android version. Then on iOS, there's WebXR from Mozilla. Everything should work. All of these should work on all 3 of those. They pretty much are functioning off of the same spec. So anything built with any of this will work on any of those. The runtime currently that has been used is Three.js. You can do it in pretty much anything you want, but all of the tooling exists around Three.js. So I'd probably stick for that unless you feel like doing lots of math. And you should probably use a helper library. There's 2, again, from Google and Mozilla. There's 3.ar.js, which is what we have been using at Unity. And there's 3.xr.js, which is maybe a little bit more complex because it handles both AR and VR. But it doesn't have any kind of helpers, whereas 3.ar.js handles a lot of heavy lifting for you. And it's built as a sort of extension on the WebVR 1.1 spec. So in terms of actual kind of complexity on your side that you actually have to deal with, there's very little. It's super easy to use. So actually working with it, all of these examples I'm going to show are all 3.ar.js. Like I said, that's what we've been using, and it seems to be the most popular out of all the different options out there for you. So first thing you actually have to do when it comes to doing any sort of AR with Three.js is you have to get a display. This is essentially requesting the browser that's running it, hey, I want to show some AR, please do what you need to do and give me back the display. And then from there, you would just set up whatever you need to set up and kick off an update loop. If you don't have a supported display, then you would either just tell the user, hey, go get a cooler browser, or show some sort of fallback experience. After that, this is pretty much identical to the normal Three.js workflow. You would set up a scene, and instead of using kind of the traditional perspective camera and stuff and control mechanisms, you would then use the AR versions. So these are all kind of like all of these 4 or 3 are all built into 3.ar.js. So they're things that you don't actually have to worry about yourself, which is really nice. So you just set up a renderer, create a scene, add an AR view that actually handles rendering all of the camera stream and everything. You set up a perspective camera, pass in display, field of vision, stuff like that, and create some controls, and you're pretty much good to go. Then from there, the next one, again, this is like identical to just doing anything in Three.js. You just create an update loop, and every single frame, you update your controls, update the view, do anything that you need to. If you've got a dancing chicken or something, you update it there, then re-render everything, request a new animation frame. It's kind of an interesting tidbit on the kind of bridge side of things. The VR display actually hijacks the request animation frame. If you want to see some sketchy stuff, just open up WebAR and ARKit's bridge. There's some good stuff in there. Maybe not for the weak of heart. So now with those three, we would technically have a fully working AR experience. You'd be able to open up on any of those browsers, walk around, you would see your camera feed behind you, and it would basically follow with you. The virtual camera would follow with you. So now to do anything interesting, you would want to, for example, let's say you want to just put a box 5 meters in front of the user. Actually really easy to do. You just have some sort of check to make sure that the boxes haven't already been added. Check that there is tracking is actually happening, which would be this has valid pose, which we'll get into in a second. And then if there is a valid pose, if the camera has actually started tracking things, and if the boxes haven't been added, then it's going to go ahead, create a box, lovely Three.js, and then it's just going to set it relative to the camera position. This is kind of a hacky way of doing it. A better way of doing it would be to take into account the actual forward direction of this cube's position, but this would work just fine. You just might have some interesting side effects. And then just tell it, hey, boxes have been added, don't do this again, please. And this guy, this has valid pose, is actually really simple. You just have to make sure that there are positions there. So this would totally 100% work, and you would be able to walk around. The second you start it and it gets the camera position, a box would be placed however far away in front of you, and you could actually walk around it and look at it, look underneath it, all of that fun stuff. So if you want to do something a little bit more interesting, maybe, like say you're really into planes, it has full, all of the WebAR specs have full support for all of plane detection. So you can actually get these events for plane added, plane updated, plane removed. All of them kind of take this structure. So each one gets a VR plane event, has the display that's currently active, an array of all the planes. Each plane has an identifier, model matrix, extent, and an array of vertices. These are kind of intimidating at first, but they actually translate really well to Three.js. And all of the kind of plane visualization just uses this, listens for this added event, creates a mesh based on that with that identifier, and then every time it's updated, it just checks, hey, has this changed? If not, then it doesn't worry about it. If it does, it just kind of updates the size, updates the position, whatever it finds. So say we wanted to actually use this. First, we would want plane visualization. The easiest way to go about this without writing your own, which I was going to add in here, but then I realized it was going to take way too much space. There's in 3.ar.js, there's actually a built-in AR debug, which has plane visualization built in. So you don't actually have to worry about it, which is awesome. And you just set that up, set that guy up, add true to show planes, and then boom, you've got plane visualization. You can walk around, actually detect everything. You don't have to deal with any of the crying that's involved in making it yourself. So now we've got it. You can see it. You want to add something onto it whenever you tap. Again, thanks to 3.ar.js, it's really easy. Just wait for a touch event. If there is a touch event, then we just translate the coordinates. We do a hit test, which is built into the WebXR spec. So it actually has, every implementation will already have this in. You don't have to worry about implementing that, which essentially will just toss a ray from wherever you've tapped forward, and if it finds any planes or feature points that ARKit or ARCore is tracking, it will just return all of those in a nice little array based on however far they are from you. So like in this instance, we just want the first one that comes up. We don't care. So we just check, are there any hits? If there are, let's just grab the first one. And then again, another handy little utility that comes with 3.ar.js. You just place object at hit. We've got my fancy box there. You toss it the hit. This one is actually an easing function. If you wanted to have it kind of like fly over to it, you could just do some sort of like linear interpolation there, and it would actually go, you wouldn't have to worry about that either. And the true all the way at the end is saying that, hey, I want this box to be placed in the correct orientation as this plane. So if this plane is like all wonky, I want the box to be wonky too. So that's all handled for you. And again, this is like why we're using 3.ar.js, because otherwise you would have to build all this yourself, and it is a pain. And surprisingly enough, like that's pretty much it. To make your own AR thing, like that's all. It's got, if you're using 3.ar.js, it's all built in for you. This is another one, like we've been placing stuff all over the place, but we haven't actually used anchors. It'll work fine, but it might be a little bit floaty. So there's this handy little AR anchor manager. You toss that in as a singleton, and any 3JS object that you add to that, it'll actually, on the native side, create an anchor for it. So ARKit and ARCore will actually take those into account whenever it's scanning and building up its map of the environment. And they'll be a lot more stable. You'll have a lot more stable of tracking on those particular objects. So if you have an anchored point, like an anchored box here, you have a non-anchored one here, if you really move around a lot, you'll see a lot of kind of floatiness in the left one, but the one that you've actually anchored will generally stay nice and exactly where you put it. And the API is super simple, so it's super easy to add. And now kind of so you can see what is possible with WebAR, this is something that we've actually built. I'm going to fast forward to a couple parts if I can find my mouse. So this is all running with JavaScript. So we've got this fancy little portal. You walk in. These dudes pop up. They say, what's up? And all of this, like, this doesn't have any plane detection or anything. This is just, we wait for that camera pose. The second that camera pose gets there, or we get the camera pose, we place this portal relative to wherever the user is. The actual portal stuff was kind of, it's far outside of the scope of this. It was a real pain. But here's like one of the coolest parts. When you look back, we've got like this Webgl Stencil, so you can actually see it out to the outside world. So this is all running on JavaScript. Like one of my coworkers has an iPhone SE, and it runs at 60 FPS on that. It's really cute too. That screen is so tiny. It's so tiny. Ah, simpler time. But that's it. There's my Twitter if you want to yell at me. And yeah, if you want to, I actually have that on my phone, so if you want to check it out in person, just let me know. Yeah. Thanks. Any questions? Yeah.
So you reference or said on the native side, so what do you mean by on the native side? Do you mean the browser?
On the native side, like the Objective-C or Java or C++ side. So all of these, like I'll share the deck. All of those, I've got links to all of those browsers that you can use them in. Essentially, you just have like on for example, iOS in your Objective-C project, you've got a web view that just handles all of this kind of for you. So it initializes the ARKit scene or session. It manages it for you, and then it evaluates that on that web view in the JS context. And the bridge has some exposed values that it passes that data into. Any other questions?
All right.
Cool.
Thanks, Matt.
Yep.
All right, next up we have an extremely short ad from these guys, and then a 10-minute break.
This is probably going to be in the background. We don't have anything prepared. It's an ad hoc approach. So we are from Helsinki Entrepreneurship Society, the first tech, the first entrepreneurship society for tech people, and we are planning to organize a bootcamp for coding bootcamp for entrepreneurs in the midsummer, and we are currently looking for people to support us. We haven't yet finalized the teacher. We have a few candidates, and we are hoping that if there are any people with experience in teaching here, maybe you could come and talk with us during the break, or if you have experience in desire to help the students during the bootcamp, you can also come and talk with us during the break, or if you're just a software developer who has an inclination towards entrepreneurship, we will also be there and we can talk with you. It will be great to have
Right.
it. Yes.
Okay.
And you're gonna be hanging
I'll
around,
just.
so-
Yes,
just
definitely,
take a minute.
definitely. You do
So
have.
if you're a bit thinking why I'm wearing this kind of formal clothes, so I can wear this one more tag. Actually, I'm coming from this. I just attended this event just 10 minutes before. I was just walking from, and there was like bunch of business people selling, marketing, technology, and everything. And if you've heard about this very famous essay by Mark Andreessen, "Software is eating the world," and the new thing is JavaScript is actually eating the software. So that's the whole kind of thing what we want to build. We want to support people who are interested in learning how to code, and we will be really glad if you can join our society. You can look at our website, HelsinkiJS.com. Right now we are about 10 people, but out of them 8 understand technology. And we are going to run this not for doing some events, but we are going to build some products which we are going to scale. So please join us. Thank you.
Thanks.
Yeah, okay. Let me start from the beginning. Demokraatti is a Finnish newspaper founded in 1895, so they're not exactly a new kid on the block. And the same can be said about their online counterpart, demokraatti.fi, which also has existed for years and years. And so long, in fact, that their old site, built on top of WordPress, could only be described by one word, which was legacy. And it could not compare against some of the nation's top publishers, such as Yle and Helsingin Sanomat, for example. So in late 2016, Demokraatti decided to up their game. And even though their readership was much smaller than those of the biggest publishers, they still wanted that their user experience should be on par. And they contracted us to make this happen. My name is Niko Myllynen. I work at Namia. We do some sweet stuff for the web. And you can find me online with this easy to remember handle. And my plan today is to tell you how Demokraatti went from a Class B online presence to a Class A online newspaper. It was a bumpy road. Here's the timeline. Our initial commit was made in late 2016. First beta version went live early next year. And September that same year, we made a change of direction, or a reset even, in the project. And production went live early this year. And I'm going to try to tell you what happened during those 18 months, what we learned, and what are the key takeaways from this project. I'm going to divide this talk into two parts. Part one is going to be from the beginning of the project up until the reset last year in September. And part two is going to be from the reset onwards until the launch of the site. And furthermore, I'm going to look at this from two different perspectives. First, a technology perspective, and second, a process perspective. So let's get started with the technology point of view. In late 2016, we were primarily a digital agency focusing on WordPress projects. And the old Demokraatti site was also built by us years and years ago. And the theme was also a custom-made theme by us. And we were using 20 or so WordPress plugins, some of which custom built by us. Some were contracted from partners, and some were freely available WordPress plugins. However, with the renaissance of JavaScript going on, we had been experimenting with Node and React as well. And when Demokraatti approached us with the idea to redo the site, it all clicked. We thought JavaScript was going to be the perfect choice for the new site, and it would also solidify our mastery of this new technology with React and Node. But in hindsight, this might have been too big of a bite for us at the time, since we only had one developer who had sufficient experience to even try to attempt something this big. We had another developer who had to learn not just Node and React, but also ES6 on the project. We also had two pairs of helping hands, part-time developers whose experience varied on a similar scale. Just to give you an example of the sophistication during that time, even though we had Redux implemented, prop drilling was our preferred way of getting props to components and doing state management. And prop drilling was not the worst part. We also had no separation between container components and presentational components. No, each component just did their thing, and if any logic was required, we just slapped it onto some appropriate lifecycle method and called it a day. And if we couldn't find a good lifecycle method, then we just used the render method instead. And if multiple components did similar things, we just copy-pasted code from one component to another and modified it slightly. And this is easy to criticize in retrospect, but when you're just trying to make things work in the first place, elegance is not a priority. And it was not just us who were unsure how to make things with React. The community wasn't either. Create React app was not a thing, and there were dozens of competing boilerplates, all of which did their thing a bit differently. So we didn't even choose a boilerplate, we just built from scratch. And Webpack was part of our solution from the beginning as well. We understood it was necessary for hot module reloading, etc., but we didn't really understand how it worked. Our initial approach was to set it and forget it. If it works, don't mess with it. But when problems arose, we had to dive in and make sense of the thing, which was easier said than done with the documentation at the time. Another problem was with styles. At first, we went with Sass, the preprocessor we were so used to from other projects. And we also did what we had always done, use small individual SCSS files compiled into one massive big CSS style sheet. And to make this maintainable, we used a lot of variables, mixins, and functions with for loops, for example. But in time, this became counterproductive since the styles grew so much that maintaining these functions and mixins and for loops became cumbersome. And since we were compiling into just one gigantic style sheet, the compile time grew to over 10 seconds. And if you're using hot module reloading, you can understand that this makes the developer experience quite horrible. And to make things worse, we were also using server-side rendering manually. Don't do it manually. So, moving on to the process perspective. Now, we are an agile company and have been for years. Our entire business model is based on the agile methodology, and it has worked very well for us. But in late 2016, our maturity in the method was maybe not as good as it is nowadays, since according to Agile, every sprint should have a visible outcome, something that can be interacted with by the customer. But in the beginning of the project, it was not uncommon for us to just work on some back-end stuff that produced nothing visible to the customer. And this would be fine in waterfall projects, but having worked for the government and buying IT for over 5 years, I know nothing good ever comes from waterfall projects that are larger than trivial. There was also a lack of urgency plaguing the project. Since we were doing things in an agile way, the plan was to release the project when it was good enough. But if you have a working site to compare the work in progress site with, you tend to get quite hungry. And there was an understandable reluctance to release anything that was not as good as the functioning site on any level. And this was amplified with the problem of money. The customer could only spend so much each month on the project, so we could only allocate maybe a few hours for one developer per sprint. So this really killed momentum in the beginning of the project. But to continue with the agile theme, I think on some parts of the project we were too agile. While our technology was in flux, the design was as well. partly due to changing demands by the customer and partly due to changes in artistic direction from our part, the design kept on changing. And often from sprint to sprint, there were changes, small and large. And I'm not saying that a design should be pixel perfect before a single line of code has been written, but I am saying that the most prominent elements and the general layout should be agreed upon. According to my experience, a design should either be a wireframe or pixel perfect, and not something in between that trusts the developer's imagination to work out the details. Because that imagination is hard at work, trying to work out technological problems instead, and trust me, there is no room left to get creative on two fronts at the same time. And to top things off, we were also not going for something you might call minimum viable product. No, we were going for something beyond that. If you know WordPress, you know widgets. Widgets are something that the maintainers can click and change the interface without touching a piece of code. And since we were used to WordPress, the customer was used to WordPress, of course we would have widgets as well. And the plan was that the front page was going to be entirely comprised of widget areas, and the journalists of Demokraatti could log into the new site via WordPress, and in the interface itself, they could choose how many widgets each widget area would have, how many pieces of news each widget would have, which category these news would come from, what the news would look like, and there were 6 different options. And this all worked in all breakpoints. And we actually implemented this. And it never got used. So when September 2017 came about, the project had been brought to a halt. Basically all momentum had stopped during the summer, as happens everywhere in Finland, but there was no huge enthusiasm to continue the project as is. The customer was unhappy with how the site worked and looked, and we were unhappy with the technology beneath the surface. But we made a reset and started the project anew. Now this may sound like a huge catastrophe, and in a way it was, but in a way it wasn't, since the customer hadn't spent huge amounts of money because progress had been deliberately slow. And while we had been learning about technology, the customer had been learning about what they actually wanted. And the design that had been in constant flux had now found a guiding star to follow. So, part 2, from the reset onwards and the technology point of view. In late 2017, we were no longer green React newbies. We had gained considerable amount of knowledge under our belts from other projects due to the fact that Demokraatti only required a fraction of every sprint's effort. So the first thing we did was to use Next.js as our boilerplate. We had had excellent experiences with it from other projects, and it seemed like the obvious choice here as well. It immediately solved all problems we had been having with server-side rendering, routing, code splitting, and so forth. It hid all this complexity, including Webpack, from out of the way and let us concentrate on the actual business logic. Also, prop drilling was a thing of the past. We had not only embraced Redux, but also implemented Redux Saga to use side effects to our advantage, which we were now comfortable using. Also, component separation was now a thing we did, and it was the agreed upon way to move forward. But by no means perfect. We had accomplished the separation between container components and presentational components, and also moved often used logic away from individual components and into utilities and helpers. We also wanted to change the REST API we had been using into a GraphQL API. And we really wanted to do this, but the WordPress GraphQL plugin just wasn't ready enough, so we couldn't take the risk. But if we were faced with the same decision today, we would take it, and my advice to you is ditch REST if possible. Also, Sass was a thing of the past. We had moved on to styled components and never looked back. I have to say I was first horrified by CSS in JS, but nowadays I've become a believer. The advantages are just too great. We had also used a number of caches to get speed, Redis on the Node backend, cache on the WordPress backend, and also a service worker in the client end. So, what changed about our process? Well, we had sorted ourselves out with our agile process. Each sprint would have visible outcomes that the customer could see and interact with. And the lack of urgency was now fixed, and this project was made a priority, and sufficient resources were allocated. We hired a new developer to work on this project, and we even set goals and deadlines, and we reached them by some miracle. Like I said, the design had now found a guiding star to follow, and it was made pixel perfect, so it was possible for developers to implement it. And our ambition level was reduced to a more maintainable size. No more widgets, no more choosing of styles or colors. The design was now good enough, so we didn't even feel a need for this anymore. And this is not to say that there were no difficulties. There were, but we were now smart enough to tackle them. So, to recap what we learned from this project. React is difficult to get right. React and Redux is even more difficult. And if you add SSR, custom Webpack setups, sagas, esoteric boilerplates, and such things to the mix, you're in for a wild ride. And it's not a good idea to learn these in a big project. So learn them in a small project instead. Also in a big project, plan ahead and coordinate your efforts. Have your senior developer tell others how things are going to be done, and then justify why they're going to be done in such a way. Also, don't do things manually if you don't have to. This applies to not just Webpack, but also state management, server-side rendering, all this kind of stuff. Use Next.js. Also, REST is obsolete. Use GraphQL if possible. And trust Agile. It was developed for a reason. Requirements are not only going to change, they're going to change all the time. So build stuff in a way that prioritizes maintainability over everything else. And set goals and deadlines, spend money. If a project is important, it should be worked on and not set to the sidelines. Thank you. Any questions?
Since you migrated from using Sass to styled components, have you found any limitations in the styled components that Sass was providing to you?
No, quite the contrary. I think the styled components that can do more than Sass.
So are you using any post-processing tools to generate any advanced, like, for example, audio prefixes for the styled components, CSS code?
No, we're not using those.
And then the next question is, why would you pick Next.js for the server-side rendering opportunities or instead of the React router, and what was the general thinking behind picking Next.js as a tool?
Well, the first thing about Next.js was the server-side rendering thing, because it makes it really simple compared to other boilerplates. Yeah.
So are you using the Apollo client for GraphQL?
We are, yeah.
Yeah. How is it working with Redux? Are they sort of trying to?
Yeah, well,
there's like last autumn is what like a mismatch. They were talking about how you could replace Redux with.
Well, in one project we replaced Redux with the Apollo client, and it works fine. But in my opinion, it's really verbose using the Apollo client compared to Redux. Maybe it's just being used to Redux, but I don't know. It works.
So for state management, if you could go back, or if you would start the project today, would you still pick Redux?
I think we would, yeah, but only because we've got Redux nailed down now, because we're so good using it. But if we were used to some other tool, I think we would go with that. It's more about being comfortable with the tools you're using, I think. Yeah.
Do you use like the TypeScript?
No, we don't.
Why not?
We've experimented with Flow, and it's going quite well. But with TypeScript, I think maybe not me as much, but some of our people are just horrified with the different suffix of the file name. So that's like too big a stepping stone for us.
But what do you think?
Yeah, there could be benefits. I'm not so deep into TypeScript.
You should try it.
Yeah. I think we should.
Yeah. So did you write a lot of unit tests or automatic tests?
Yeah, we did. I think not that much. Our coverage is about 50% or something like this. Hey, have mercy.
All right, more questions? I guess not. Thanks, Niko. Andrey, stage is yours.
Where's your dream?
I drunk it.
Already?
Yeah, I drunk.
There's longer. Just beer. 3. This is the. Well, this is the third one.
Yeah. I'm fast drink.
Okay. I drink very rare.
Okay.
Only like meetup.
Yeah, me too, but I had like a very.
You are thirsty.
No, I mean, I had a very, how do you say, intensive yelp or something.
All right. We're in the stream at the moment. Petri, olis me striimissä? Joo.
At least for application. Of course, REST is good for small websites, but for applications,
Sorry, can you begin again?
Okay. So, hello. Niko said a very good idea that REST is dead, at least for application. For small website, it's still good, but for big complex application, REST is dead. But let's talk further. Let's talk what ideas could be used for client-server communication after GraphQL. And so this is my talk about CRDT and other ideas after GraphQL. So I'm lead front-end developer in Evil Martian's team. The company behind PostCSS and After Prefixer, I think you use it. Here's a Twitter of Evil Martians. You can find the slides there. So, CRDT. Who knows CRDT? Who even heard it? Yeah, this is not so popular, but it started becoming more popular. For instance, Atom Teletype, like it's a text editor, but by GitHub, and Teletype is a feature allowing collaborative editors, like when a lot of people change the same document and they works like fine. Same feature for Visual Studio, like it's called live sharing, and both of these features implemented by CRDT. And also like Redis implements CRDT in their database, so CRDT become more and more popular thing. So CRDT is the only one choice if you have one document and many users edit this document. Unfortunately, right now it's only one choice. But I'm here because I believe that CRDT could be used in any application, in any regular web application. But why do we need a CRDT there? We have a very good native clients. We have a very good web, like we have a Redux, all this stuff. It works really good. And also we have very good backend. We have a stagnation in PHP and Ruby because there is nothing to change. It's everything fine. But between these two good things, the bad things hidden. It's a server-client-server communication. I believe that client-server communication is very bad right now. So, why I believe in it? First, we have a lot of technique to offline works. So our application will work offline. But unfortunately, all these technologies like server-side workers, progressive web app, and all those stuff, they care only about open your application. But all these technologies don't care what you will do with data in this application while you're offline. And this is a big problem because we will have a next billion users with a very bad internet connections. And also it's not only a problem of next billion users with bad internet connection, like New York, the capital of the world. Unfortunately, they don't have an internet connection in the subway, like in the tunnels. And the core idea of any wireless connections, it doesn't work sometimes because of the tram or something. But why our application works so bad with offline or like maybe not long offline, maybe like losing a connection for a few seconds? This happens because when we're developing an application, we run backend on our same machine. And as a result, while we are developing, connection between client and server is perfect. But unfortunately, when we run backend on the real servers and clients will use real connections, and things will be a little different. And developers have no time to care about it. I don't care about all these problems, and I think most of you don't care about it because we have a hobbies, we have a family and something. So, today I bring ideas which could solve the problem. And as any journey, we will start with some initial targets that we try to achieve. And with these targets, we will solve the first problems, then we will find a new friends, and then we will find our main enemy, and we solve it, and then we will find that all problems with connectivity will disappear. So, what is a reason for our journey? Let's choose few features that we don't have in our modern application and try to create some solution for these two features. So first feature, I think it's any application will be better with this feature is real-time updates. Because if your application have real-time updates, user will have always see the latest state of the document. Right now, if user open a document and then other user saves this document, and then first user saves the changes, they will overwrite each other, and like these changes will be missed. And it doesn't mean that you need lifetime updates only if you have like multiple users. Right now, your single user have a lot of clients. It can open a website in multiple web browser tabs. It can use mobile and desktop in the same moment. So even you have one user, you have a multiple users right now. It's true. Second idea is idea of optimistic UI. Who knows the idea of optimistic UI? Who read the article? Yeah, it's pretty good idea. So right now, when you try to save something, to press some button, you see a loader, and so you must to stop a work. And it's very bad for your thinking, because if something block your like flow, you can forget. It's just a bad thing. Much better approach if you press the save button, it's save immediately, and then you continue to work, and it saves somewhere in the background. So these two features will make any application better. For instance, because any performance achievement increase a profit. It's like there is a lot of examples how performance increase profit. Okay, we decide to make these two achievements. Let's start preparation. First, of course, we will not talk about jQuery websites. We will use some HTML templates. So we will have a user send a click change the store, and store render to HTML. Like this is React. I think everyone understands it. So next, instead of the listening clicks, we will have some controller which will convert the clicks to the actions. Actions is a simple object which describes what was actually changed. And then this action will change the store. But again, this is just a Redux, something similar, like actions from the Redux, in any frameworks. Why we prepare it? Because right now we will be focused on a very simple idea. We have an input channel of actions, and these actions must change the store, and the store somehow render to HTML. So we care only about actions in the input and store in the output. Okay. First enemy. First enemy to implement live updates, we need some connection, two-way connection to a server. So we can't use Ajax. For instance, to have a two-way connection to send some data from the server to our clients, we can use HTTP polling and WebSockets. We can use server send events because they have no edge support. My favorite is WebSockets, of course. Who heard that WebSocket doesn't work in production because of old firewalls? No? Okay, just use encryptions. If you use WebSockets, always use HTTPS encryptions, because it solves a lot of problems, not because of privacy, but of course also because of the privacy, but because encryption solves the problem with old firewalls. Okay, next problem. We have a WebSocket. How many people here have a PHP or Ruby backend? You know, sometimes you can just have a WebSocket connection to a PHP because like it's very bad in concurrency. In this case, the solution is very simple. You run a Node.js proxy or like Go proxy or Lang proxy, like depends on your preferences, and this proxy keeps WebSocket connections. But then this proxy sends HTTP request to your backend, and if backend want to send something to your clients, backend send just simple HTTP request to Node.js proxy. It will solve the problem. Okay, it is easy problem. Second problem. We have WebSocket connections, we have our application. What we need to send by WebSockets from the server to a client. First idea, we can send the state, like the whole big object which describes our states, like Redux state. But if we will send the whole state, it will be a huge. For any small actions, we will send a big state. It will be a bad thing. But also, if we will send a state, for instance, the documents, the full fields of the documents, how we will merge the changes? What if two users in the same moment save the same document with a different fields? How we can merge it? Like this is alcohol in Chinese. So in the Redux we have actions. What was actually changed? Let's just send these actions. In this case, we don't need to merge the states, because if users change the different field, like likes and title, we don't need to merge it. It changes different fields. And with actions, we can make a very easy like mirrors. One client change the document, send actions about these changes, and then we just resend the same action, same Redux action to all our machines, all our clients. Okay, next. We take care about left updates. Right now, we must take care about optimistic UI. To take care about optimistic UI, we need some background sync process. So, user change the document, change the state, like send action, this state will be immediately update the interface. So if the user change the name, we change the name immediately in the browser. But then in the background, we send it to the database, to our server. And in this strategy, we have a problem. We show to a user that user change name. But what if client have no connection? We have no idea about the connection stability when user changes the name. We can understand that there is no connection only if we will try to send something to a channel. In this case, of course, the solution is very simple. We just need a list of ongoing action. So when user changes the name and there is no connection, we just put this name to a list. And then when we will have a connection, we just send it. Second problem, and this problem is more complicated. What if we send our action to a server, but then server can't apply it to a database? For instance, because of the database error, or because somebody already took this name. Especially the problem is very complicated because, for instance, if user change the name and then post a comment, this comment will have the name of the user. But only after the second action, we will know that server can't apply the first action. So next actions in the Redux can be connected to a previous one. How to solve this problem? And to understand it, we need to go to a functional programming. No, it's very simple. Like the only one idea that I will describe is pure function. It's a very simple idea that pure function is function which rely only on the argument. It doesn't use some states, it doesn't use local storage, cookies, nothing, just arguments. And it's returned. So with same arguments, the pure function returns the same value. It's a main idea of the pure function. And if they return the same value, we can call it again and again. It will not change something inside. It will always return the same value. Then we will split our complex business logic by two systems. First system will change the state, and this system will be pure function. And second system will be not pure. It will be middleware, for instance. And so we will use reducer to change a state. And again, this is just Redux. This is not a complex stuff. Redux, Elm, and Vux has the same idea of pure function reducers. With this idea of pure function, we can call our reducers which change the state many times. So, for instance, we have three actions. One action, we apply first action, then we apply second action, and then we apply third action, change our state. But then our server sent that this action could not be applied. The name is already taken. In this case, because we can call reducers again and again with the same result, we can just take our first state and then apply the same actions, but without the invalid action. So with the pure function of Redux, we can change the history of the project. In any moment, we can go backward, remove some actions, and then apply our reducers again. This is already implemented in Redux. This is not rocket science. Who used Redux DevTools? Do you remember the history time traveling? This is the idea of history traveling. And so we use history traveling to remove the action from the log. But also, if we remove the action from the log, we need to show to a user that action was removed. But we can do it not only in the document form, we can do it globally, like in the global notifications. So with Redux history, Redux time travel, and with global UI, we can solve the problem when server will undo some action. Okay, but now we have a more complex problem, and now we are coming to idea of CRDT. First idea, of course, okay, we have a Redux on any our clients. We have a list of the actions on any our clients. But will this action list will be the same? What if on one machine it will be one order, on different will be different order? In this case, the final state will be different, and it will be disaster. There is no solution in the distributed system. Okay, of course we can just sort our action by a time, but unfortunately if we use timestamp, it will be not a solution because any client have a different timestamp. There is a timestamp just doesn't work. Second problem. Okay, we don't send a whole state, we send only the changes. But what if two users change the same field of the document? For example, two users change the like count. How we can merge it? Because it is the same changes. And to solve with these problems, we need a new friends. So first problem, first friend candidate is operational transformation. Maybe somebody here, like Google Docs. You all use it, yeah? And you know that you can edit the same document at the same time. They do it by operational transformation. So how it works? First, how they solve problem with the time? They don't generate a time on the client. The server generates a time. When client create action, it sends it to a server, and server put a time according the server timestamp. So no problem. Second, how they fix the problem with merging two changes. When server receives the first action, and then it receives a second action, the server will change on the fly the second action. Some sort of time traveling, but the main problem is so complicated, it's hard to me to explain the idea of operation transformation. It's much harder to write it. So unfortunately, operation transformation is not an option for us. Let's go further. Okay, we need to generate time on the client, and this time should not have any problem of the timestamp. Let's just forget about time. Like, it's very easy. So, it's called a logical clocks. The idea that every our client have a counter, and of course unique client ID. Like it mostly random generated like UUID. So every time when our client generate time, we increase this counter. But also we synchronize the counter between machines. So if first client use counter 1, then client sends this action to a second client we use the next counter. So the counter is always bigger that you received or used. Then second client use counter number 2 because it receives the one from this other client and send it back to the system. But if two machines will create action in the same moment, of course the counter will be the same. In this case, we use unique client ID to make it different. And the main problem of logical clocks is it works very bad in offline. If there is offline, unfortunately, the counter will be the same because they don't have connections. So there is other idea. Let's just add a time to our use counter, then time, and then unique node ID. And also we can, on the connection, we can calculate the time difference between client and the server. It's not so complex. With this system, we can solve the problem with working with time in offline. So we use a counter, we use a time with correction, and then we use a unique node ID. And then, by this time, we can insert the actions in the middle of the lock with the same time travel. So if other machine will send old action to us, we will put it in the middle of our history because Redux have time travel. Okay, but our next problem, how we can deal with what we should put inside actions. Right now with our simple Redux, we don't care about what we put inside actions. We put anything that we want. Now we must find a solution. And this solution called CRDT. It's a scientific research made in just 9 years ago. So we can sell alcohol to them, to this paper. It's conflict-free replicated data types. It data types with a lot of limits, but inside these limits, these data types have no conflicts. There is some operations, and you can apply these operations in the same, like two clients can change the same document in CRDT, and they will not have a conflict. There is two types of CRDT. First is operational-based type, second state-based CRDT. It means that first one, it's similar to Redux. You have a list of the actions. The second one, you have a state, like the final state. Like there is a mathematical proof that these two systems equal. But I prefer more operation-based CRDT because I like Redux, I like this whole list of the actions. But in the practice, most of the solutions use both together. Okay, so what does CRDT means? It means that inside your Redux actions, you make your Redux actions atomic as you can. For instance, we have like counters, like like in Facebook. And so in Redux action, instead of the exact value, we just use increase and decrease. So our actions become very atomic, and we can like put it together without any problem. This is a type from CRDT. Second idea is map. In this case, we don't like put the whole map, but we inside the action we put the new value only for one key. So if we change one element of our map, we put only this element to our action. So it's easy. It's obvious. Main problem. Okay, the map. In the map, who changed the field the last editor wins. So if two clients change the same fields, like name, the client who changed it in the last, their value will be used. But what if we need to allow people to change the same text in the same moment? For instance, we have a cat name. And we want two clients. One client wants to remove the first letter, and second wants to put a H after first symbol, after first letter. How we can merge it? First idea. Okay, let's put to the actions the number of the characters, the number of the symbol. So if one user deletes first symbol, we create Redux action, delete the symbol in the position 1. And other client will add H to after position 1. Unfortunately, when we apply these actions, when the first client removes the C, the meaning of the first will be changed. So unfortunately, it's not the option. We need some smarter solution. And so there is an idea inside CRDT. Let's not use indexes. Let's use unique numbers. Initially in the cat, we have 1, 2, and 3 in number for any symbol. But when somebody inserts H between C and A, we don't set it to a 2 because it's already taken. We take a number between 1 and 2. In this case, any any symbol will have always unique number. So if somebody remove C1, we will not change the number of next symbols. In this case, we will not have a problem with merging it. And this is how all these systems like atom teletypes works. They have unique number for each symbol. So what we need to put on our server? First, of course, we can have a list of the action on the client and a list of the action in the server. For instance, it's the best idea for counters. Or we can use list of the actions on the client and we can save the state on the server. For instance, on the client we have the actions which describe that we change the name to a new value, but on the server, for every field, we have a time when this field was changed. This is a state-based CRDT. Or for instance, we just can ignore CRDT on the server side. for instance, if for text, we need CRDT only if somebody connected to our server. If there is no users, we can just send just a text. But CRDT is much more complicated, much more. But all this complicated stuff is underground. The main idea of CRDT is very simple. Just create the Redux action in the most atomic way that you can imagine. So, a lot of math, a lot of complex ideas. Why do we need it? Because first, we can create also nice ideas around them. Of course, we can save ongoing actions to our index database. So in this case, our client can close the browser in the offline open and then send actions. But also there is a very nice background sync API. You can ask service worker, in service worker, you can ask browser to send the data when user will be online, even if user close your website. So I'm in the subway. My grandma asked me, "Are you alive?" And I need to answer her. So I just write, "Yeah, I'm alive on the subway," but this is a New York subway. There is no connection there. So in this case, my application will put this action with new message to an index database, and then I will close my browser. When I will go to ground and got a connection, browser will execute service worker and send this message to my grandma. And it really works right now with Chrome. Second idea. All this CRDT, it means not only to synchronize changes between two clients, you can also use it to synchronize changes between different servers. So it's very good in terms of scale. But also my favorite idea, with all these CRDT ideas, with all this synchronization instead of changes, you can synchronize, instead of having a connection to every browser tab, with CRDT you can elect the one leader browser tab. All other browser tabs will be connected to these leader browser tabs, and only these leader browser tabs will have the connection to a server. And it's not so hard to implement. This is the whole election algorithm. Okay. All these ideas, a lot of complicated stuff, but also it's hidden one very big problem. I told how easy it is to put actions to a lock, but in this case, lock will always increase. We need some solution to remove actions from the lock. First idea, of course, we can remove, if one action override others, we can remove previous actions. Also, we can compress actions to a single value. But it's very complicated to write this custom logic. And sometimes it's impossible. So with all this system, I believe that you can implement CRDT only if you will not try to achieve 100% ideal solution, because right now we don't care about offline. So if your website will be 99% offline, it will be much better than 0%. So how you must to clean log from the actions? First, keep unsent actions, then keep actions according to some custom rules, and then keep the action for last hour or something. All other actions could be removed. In this case, you will solve the problem with the length of your action list. Okay. Why? Why do we need all this complex solution? So, first, we have actions. For every action, we have a time. We synchronize actions in the background, and we use time travel to put action inside in the middle of log or to remove it. And we use CRDT to make our actions atomic. Why? First, because in the result we will have optimistic UI. The really true, good, and optimistic UI, and our interface will be faster. Faster means more money. Second, with all this idea of CRDT, we solve a lot of the problem of live updates, and so we can implement it out of box. It will be very stable. But most important, with all these ideas of background synchronization, we can just ignore about Saga, Redux Saga. We can ignore about a JAK request. All these ideas is in the background, in the framework. But in the result, for developers, all you need to do is to add some action to Redux. And that's all. All this magic will be happening inside, in the background of the framework. Framework will be send this action to a server. So you don't need to make a JAK request. You will have Redux action on the server. So your code will be simpler. And also, like, without all these creepy technologies, we have a lot of problems. For instance, there is a user. User click to the checkbox. The checkbox saves the data to in the background. Then user clicks the same checkbox again. So in the result, it's put to the on. But unfortunately, in the real internet, if we will use not all these technologies in the background, but if we will just send a JAK request, the first JAK request could be went to a server later than the second one. It happens every time. Unfortunately, it's the reality of the internet. If you use all these technologies with crazy time and CRDT, you don't have this problem because your action have a time. So when the second action will be on the server before the first action, this action will be saved to database. But when the server will be receive the action from the past, like the previous action, it will ignore it because it knows the time of this action. Or imagine like you use Ajax right now. You have a pay button, and user press the pay button, start to see a loader, but then connection stopped. What do? You don't know was the Ajax request sent or not. If you will press the button again, maybe it will make a second payment. With all these technologies CRDT, you don't need to care about it. When user press the pay button, you add a Redux action payment ask. Then, for instance, it's send it to a server or not. We have offline, then we got online. And after receiving a payment ask, our server make a payment and put the payment OK to the ongoing actions to the server. And so even if the connection was in the between, when the connection will be online, the client will receive this action from the server. So it works very good if there is a connection in the middle of the request. And we already implement all this strange and complex ID and logax. It's already built in. You don't need to care about them. And a lot of systems right now use these ideas. For example, in the Trello. Who is Trello? They work with optimistic UI. You don't need to wait. And they use the same ideas of time, with same ideas of the log inside the Trello. Same with Google Keep. It works very good. And also, there's other solution to do it, to do all these creepy logics without logax. For instance, Swarm.js is very nice. OK, so this is the end. Questions? Yep.
Godspeed. Yeah, so I have a design question in regards to optimistic AI.
Yeah.
So say I implement a service that's similar to Twitter or something, and I click the like button on the post, and of course it just shows immediately that it's liked, and in the background it does the server stuff. But then let's say for some reason the request fails. So what would be the next course design-wise? Would I just undo the like, or would I give an error to the user saying, hey, your like didn't work? Because it can be kind of annoying to go back and say, hey, I guess it didn't go through.
Yeah, this is the main problem of optimistic UI. The good idea, you should first reduce the problems. So you should start to ask why the like could be failed. For instance, if there is no connection, like right now, if there is no connection, your Twitter client will not apply the like. So the first idea, you should make your system in the way when the offline it is not a failure. This is the first step. The second step, unfortunately, yes, sometimes database just doesn't save the records because of some internal problems. In this case, I believe that you must, there is two options. First option, you just undo the actions, like you undo the like, and show some like global user interface that actions was removed. It's not so good, but it's okay. But for likes, you can do smarter way. Because of this CRDT, because of the time, you can send the action to a server. Server try to apply it to database, fail. Okay, server will put the action to a list and wait until you will come, fix the code, fix the database, and then run all received action again. For likes, it is the best strategies. So with all CRDT, you can run the actions again on your database. And this is a solution perfect for likes. Some other questions?
I was just interested in like maybe more technical details. Is there some like
even more?
but I mean like is it like this logax? I just checked quickly. Are there some good examples or like some maybe sample app where you can just kind of play with this technique or see how it works?
As you saw, these technologies, these ideas, it's pretty new. So to be honest, right now there is no like pretty good CRDT implementation at all. Our CRDT implementation just bad. So this is really the age, unfortunately. You can try to Google like logax example, and few developers they already wrote the example. And also in the next week or maybe next month, one developer will publish the article about how he applies the logax. Unfortunately, right now, it's very edge technology. Sorry.
Thanks.
All right. More questions?
So let's start with Rinko.
Yeah. Thanks, Andrey. So just a couple of things before I let you go to sauna and grab more beer. First of all, huge thanks to Fraktio and all of our speakers. We still have one event before the summer holidays. It's next month, but we don't know the date yet, so follow social media and your email for that. And we're also raffling one free ticket to FrontCon, that's in Riga, Latvia, 14th of June. But we're gonna do that in our Facebook group online, so follow that to take part. All right. Time. Thanks for everyone.